Keeping not a numbers with pandas data frame inequalities. I have a pandas.data frame object that contains about 100 columns and 200,000 rows of data. I am trying to convert it to a bool data frame where true means that the value is greater than the threshold, false means that it is less, and not a number values are maintained. If there are no not a number values, it takes about 60 milliseconds for me to run. But when I try to deal with the not a numbers, the below method works, but is very slow, 20 seconds. Is there a faster way?
You can do. But that is different from what you will get using the apply method. Here your mask has float D type containing not a number, 0.0 and 1.0. In the apply solution you get object D type with not a number, false, and true. Neither are okay to be used as a mask because you might not get what you want. IEEE says that any not a number comparison must yield false and the apply method is implicitly violates that by returning not a number. The best option is to keep track of the not a number separately, and df.icenull is quite fast when bottleneck is installed.
Another option is to use mask. This will only apply the condition to non-NaN values and leave the NaN values untouched.
You can check for not a numbers separately using this post, Python, find integer index of rows with not a number in pandas. Combine the output of icenull with df equals threshold, using bitwise OR. You can expect the two masks to take closer to 200 milliseconds to compute and combine, but that should be far enough away from 20s to be okay.
In this situation I use an indicator array of floats, coded as 0 equals false, 1 equals true, and not a number equals missing. A pandas data frame with bool D type cannot have missing values, and a data frame with object D type holding a mix of Python bool and float objects is not efficient. This leads us to using data frames with np.float64, D type. numpy.signX, threshold, gives -1 equals, x, threshold, 0 equals, x equals threshold, and +1 equals, x, threshold, for your comparison, which might be good enough for your purposes, but if you really need 0-1 coding, the conversion can be made in place. Timings below are on a 200k length array X.
If you want to see more, please consider